Good evening, everyone, and welcome to today's webinar conducted by the Institute of Engineers Sri Lanka, Western Australian chapter. Our topic today is on responsible use of artificial intelligence, presented by Dr. Buddhi Jayatilaka. Thank you, Buddhi, for accepting invitation and volunteering to lead this presentation. Let me outline how today's webinar will proceed. The webinar will start shortly after my introduction. The presentation will run for approximately 45 minutes. We kindly request that you mute your microphone during the presentation. Following the presentation, there will be a quick Q&A session. You can type your question in the chat box throughout the presentation. If you have a question during the presentation, you may raise your hand if you want. If it won't disrupt the flow, we will give you an opportunity to talk. Otherwise, during the Q&A session, you can present your question verbally. If anyone requires a CPD certificate, please send us an email addressed to secretary@ieslwa.org. Thank you all for joining today's webinar. Let us now begin the webinar. It is my pleasure to introduce Dr. Buddhi Jayatilaka, our speaker for today's webinar. Buddhi is a Chief Data Scientist and a founding member of Sapia.ai, a company dedicated to transforming organizational hiring practices through the application of artificial intelligence. For over 5 years, Buddhi has led the scientific innovation at Sapia. His research in natural language processing and responsible AI has been widely recognized through publication in various journals and conferences. Before joining Sapia, Buddhi was the first lead data scientist at Culture Amp, where he developed machine learning solution for deriving actionable insights from employee feedback data. His academic journey includes teaching roles and senior research fellowship at leading Australian universities, focusing on interdisciplinary research projects in data-driven decision-making. Buddhi holds a PhD in computer science from RMIT University, a master's in software system engineering from the University of Melbourne, and a bachelor's in computer science and engineering from the University of Moratuwa. Without further ado, I now hand over the floor to Dr. Buddhi Jayatilaka.
Thanks, Nandika. Thanks for that kind introduction. Hello, everyone. So one thing I want to just check, I can't see myself on the camera. It's showing me like a pink screen. It says the camera is blocked. Not sure whether it's a control from your side, Nandika, or...
No, we can see your camera on.
Okay, then it's fine. As I can't see myself, that's okay. So what I'll do is I will share my slides. Tell me if you can see it. Are you able to see my slides?
Yes, we can.
All right, great. Let me put that on this one. Okay. So like Nandika said, so the topic for today is responsible use of AI. So what I would like to cover at a high level are these key areas. So just a general introduction to AI. I'm sure most of you are familiar, so I'm not gonna dwell on it for too long. And then thinking about how you can use AI, and then onto the topic of responsible use of AI and what questions to ask if you are going to use AI, for your personal use as well as for any organizational use. So overall, what I would like for you to get from this is kind of like creating a mental model of this current, uprising of AI, what it means, and how you can benefit from it in a responsible way. So if you, if that's what you take away, that's exactly what I have in mind. All right. So Nandika's already introduced I had this slide in this anyway, so I think you already heard from Nandika. I've been in the industry for more than 20 years, starting as a software engineer and then becoming an academic, a researcher, and then data scientist, until I ended up in this role that I'm playing now as the chief data scientist at Sapia. All right. Okay. So I guess no one's surprised that AI is here. I mean, if you are surprised, I would say, well, it's, if you look at this chart that I've shown here, as especially computation has become miniature and has become part of our lives. AI, or kind of the next frontier of using data and algorithms to make computers do much more what humans do. That has been a goal for a long time since we built computers. And if you really think about the human race, it's not a surprise at all. We've always been tool makers, from the Stone Age to today to microprocessors. Anybody who has an understanding of microprocessor knows that how complex that is. So that's not a surprise. But yes, this innovation kind of looks a bit scary because it acts like us. So we built tools to date, but none of those tools really acted like a human. But now you have a tool. If anybody's used some of these recent AI innovations like ChatGPT, I'm pretty sure you have. Would have been great to get a raise of hands, but you can't do that when you do these things remotely. But I'm sure that it is something different. The experience of interacting with this tool is different to interacting with any other tool that we know of. I'm sure as engineers, we are tool makers ourselves, and we are users of tools. Now, this is a different kind of tool. And the second point that I want to make is that tools are always built for a purpose. And they provide a lot of value. You take a knife, but we also know that it can be used in a harmful way, in the wrong way. So safety becomes a key issue when you build any type of tool. Again, I don't need to preach to the choir. I'm talking to engineers. This is pretty well. And something that I really liked was this quote from Tristan Harris in one of his talks. I have the link here from YouTube. You can, I highly recommend listening to that. This quote resonates really well, I'm pretty sure, with engineers specifically. When you invent a new technology, you uncover a new class of responsibilities. Just think about it. Before cars or any type of new technology, let's take the car for instance. We didn't have car crashes or the need for seat belts or road rules before we had cars, and there was a reason why we had to implement those, because that the car, while it provides sort of value, it can harm us too if you use it in the wrong way. If you go at very high speeds, that can be at times fatal. So we had to come up with ways to use these devices in a responsible manner. So that's really a combination of legal implementations as well as other measures that we put on these devices themselves, like a seatbelt. And the same thing applies to AI. As you go through this talk, you will see that. Let me go to the next slide. So there's three types of points of view, I would say, that you can hear from pioneers and leaders. So the first one is, it's a rather utopian view. The idea that AI is all for good, and we will all benefit from it, no doubt. And I think there is definitely good in it, but it's only good if we implement it and use it properly. So there's a lot of value you can get from it as long as you implement it well. So this quote here is from Yann LeCun. So he's the chief scientist at Meta and one of the pioneers in the recent deep neural networks revolution, I would say. Then there are the other end of it, the more dystopian view. So there's, to me, there's two types of risks, or like, this dystopian view can be put into two groups. One is this kind of extreme view that AI is gonna take over us. It'll be, clearly will be much more smarter than humans, that we will one day, be controlled by AI, that view. I'm not sure that I see that future. So like I said, if I trust the people who are building these systems, the engineers and scientists behind them, and if you look at what we have built so far, we can have trust in these experts who build these things. I have a lot of trust when I cross a large bridge that's not going to fall down, right? I trust the engineers who built it. I trust the engineers who maintain it. So that kind of dystopian view of like AI taking over us, clearly will be a design flow rather than AI doing it, on its own. Us designing it in the wrong way. But there are harms that can come if you, don't design it. No, not that AI is going to take over humans, but there are other harms that can come our way if we design these things in proper manner. One, I will go through some of those issues in the slides, but think about how someone can use some of these fake images, fake content to deceive other people. I mean, we've had issues with elections and certain people being targeted through AI. So there are that sort of malicious use that can happen, especially now. It's very hard to sometimes say whether you're talking to a human or an AI. So there are that kind of challenges that we'll get. Not that AI is going to take over us, but it's humans using these technologies in a way that can harm other humans. And then the other is whether it's intentionally or not. You might build these systems with data that is not representative. These AI systems are always trained on large amounts of data, and if you're not using the right type of data, you'll end up with something that is not going to be behaving in ways that we like it to be. It's a garbage in, garbage out situation. So yeah, there are harms. So you can't say it's all going to be good if you don't design them and maintain them properly. But I don't think AI is going to take over humans. That's not a view that I see. But the main thing is, it's clear that we, like with any tool, the people who will use a new tool will get benefit than people who are not. You're not going to use a Stone Age tool to cut anymore. You'll use a knife because that's a better tool. So the key point here is that AI is not going to replace humans overall. I mean, I would say there are jobs that AI will disrupt, but it's not like AI is going to do everything for us. But clearly, people who use AI will have a benefit. It's like a person who uses a calculator, will obviously have a benefit than somebody who doesn't. That's why sometimes calculators are not allowed in exams. But then if they do, then you allow everybody to bring in a calculator, right? So then everybody gets the same benefit. So there's that. Yeah, so there's few codes. So the thing to remember is that we can't ignore this. We need to find ways of safely building these systems and also safely using these systems. I'm not gonna, like I said, I'm pretty sure you are overall familiar with the concept of AI, so I'm not gonna say a lot, but I want to highlight kind of few key things. Generally AI is about using data and algorithms to do typically what humans do, like using human intelligence. Now, AI system can do that for you. And when you talk about AI, there's a strong bias, right now, like, AI is about learning, machine learning, mainly learning from data, but AI is a much broader, more vast field. So there's other subfields of AI like planning, optimization, scheduling. I'm pretty sure as engineers, you've used some of these other methods. So AI is not just machine learning, but but yes, machine learning dominates because it's that learning aspect that gives the I would say the most benefit. And you could see how these different kind of methods of learning, like a picture here is a popular way of putting it. So we had artificial intelligence, which is like a broader field, and machine learning is a subfield of that, and deep learning or using neural networks is a subfield of machine learning. And today we have generative AI like ChatGPT, which are a subfield or method of deep learning that provides us with generative capabilities. Yeah, so what is generative AI? I mean, as the term says, it can generate things. I'm sure you're familiar with it. So I asked this question, for example, what is generative AI from this new generative AI based search engine called Perplexity. I'm not sure whether you're familiar with it. Try it. So you can ask questions. So instead of just searching and giving you like a bunch of search results, it will create a summary or a document for you, and then you can chat with it. It's pretty interesting. It's a a really good learning tool. So if you ask this from Google, you might get a bunch of search results, and then you have to go and read them. Instead, now you get a summary of stuff with references. So you can, if you want to go and read them, you can read them and not. Now these are these generative AI systems are trained on vast amounts of data. I'm showing you here an example of GPT-3, which is a older version of the current ChatGPT, which is now 4 plus, 4.0, the recent one. But this GPT-3, that's where the data is available. It's trained on 530 gigabytes of data. That's a lot. I mean, you can see it's around 400 billion words. Just think about how much you read, or like how much a human would consume as words in their lifetime, and you could see how these systems are going to be far more knowledgeable than us. And in this one, it has data from the web, I think various books and Wikipedia, etc. So, and it's growing. So that's one thing to remember. The second thing, and I'm kind of trying to, I mean, all of these things are pointers that I want you to kind of remember, like, if there's something to take away, so that you create this mental model of what these things are, at least at a high level, how they operate, so that when you next time interact with them, so you have that inner knowledge, about those systems. The second, I think, a key point to remember is that these generative AI mainly use a method called autoregression, or they use autoregressive models. What that is it's sequentially generating whatever it is, as an image, whether it's a text. I mean, it applies to text pretty well, because text or language is, there are sequences, and you know the sequences. A sequence of words will make a sentence, and a sequence of sentences will make a paragraph, and a sequence of paragraphs will make a document or a book and whatnot. So there are sequences, and you can see here, this is generally what it's doing. So you give it a prompt. In this case, and this is a simple example that I got from a research paper. Once upon, and then you give it. So based on everything that it has learned, it picks a word. I mean, usually it's something called a token, a part of a word, but let's just, for the sake of this example, let's say that it's a word or a character. It picks the one with a much higher probability to come after once upon. So it has picked, it can, these new models can pick not just one, but a bunch of them, and pick randomly something, or you can define how it picks the next one. But I want you to just get the idea of like how they work. So once upon a time, and then you feed that sequence again to the model, and then it picks a time, and then you can see what happens. So this is why when you give it a prompt, and when you give it different prompts, you end up getting different outcomes. Sometimes what you want, sometimes what you what you are not looking for. Say if you're using something like ChatGPT, I'm sure you had this experience. That's because of its autoregressive nature. So keep that in mind. So that will help when you interact with them. And if you want it to if you want to steer it in the right way, so you should be thinking about where to start, and giving it enough so that you have given it enough of a sequence to kind of point it in a direction that you want it to go, and that you get that outcome. So that the auto-recursive nature is one to remember. And yeah, I think I kind of, these large language models are now more than languages. Shouldn't have said language models, but they are multimodal. That means they can take various mediums of data, images and whatnot. Some of the new models, if you have seen, can generate videos, and it's just moving fast. So once you have these models, we can do a lot of tasks from them, like you can summarize content, you can ask questions, you name it. I'm pretty sure you're familiar. If you haven't tried some of these systems that I've kind of listed here, most people are familiar with ChatGPT. And there's also another similar model called Claude. You will buy a company called Anthropic. So I suggest you trying out these different models and what's out there, and then you see, like, you can ask the same question and see what the outcomes are, and you can get a sense of how these different models have their own way or characteristics, and then you can figure out like which one would be good for you for which kind of task. And yeah. So now you have this broad view of what it is. Obviously, you can see the potential of this. And the so I took this from a report from the McKinsey, the consulting company. So it shows, from like different functional areas, starting, with education and workforce training, where generative AI has the highest potential, versus not using generative AI. I think the delta or the gap is the important thing here. So you can see the potential is really high in education. I'm sure you can see that. And in business and legal professions, where you get a lot of documentation, reading, and kind of summarizing and making sense of documents and extracting information from documents. So you can see how these systems can be pretty useful. And in science technology area, again, pretty clear. Community services, and I'm not going to read through this. I recommend you kind of, when you have time, if you have time, reading this. But the point I want to make is, at the end of this part, is that I think, as engineers or any profession, any professional, you should be thinking about how you can, what problems you can solve with these types of systems. How can you kind of bring this method into your thinking, right? When you think about a problem, like you obviously, everybody has a set of tools that they think with, and I think this should be a tool that you need to have in your toolbox for any problem that you're solving, because it can clearly give you the productivity enhancement, efficiency gains. It's much faster than a human doing it, maybe much more accurate as well. There's a lot of benchmarks on those, but it is not totally displacing the human, but it's gonna immensely support or assist the human. So think about how what problems you can solve with it, and also, like, what innovations you can make in your own field, right? In what you're doing. I think there's a massive potential for this, the use of AI, and it's like a blank slate. Think about if you were there when the web, in the I would say early 90s, when the World Wide Web came into being. Everybody started thinking about web-based things. We already had software that was running on desktops. So this was a sudden change where slowly people wanted everything web-based. Now today we don't really say you need web-based. By default things are web-based. If it's not, that's a problem, right? So at that point there was a disruption that you suddenly had a chance to kind of create what was existing in a web-based format. And I think the same thing is happening right now. So there's an opportunity for you to think differently about a problem that you're solving already, but how do you solve it with generative AI? Does that give you gains in quality, in productivity and whatnot? So that's something to think about. All right. okay, a little bit, a few pointers again around like how you might be able to solve problems through this. This is a common way to think about whether you buy or build. So you can buy as in like use an existing model like ChatGPT, you pay for it and then you can use it. You can connect it to your system through, not always having to type through a chat interface, but there are things called APIs that you can get a software engineer and you can connect that to your system and kind of use it in your backend. So that's much faster. But one thing to keep in mind is then you'll be sharing your data with OpenAI or whoever the provider that you're using it with. So if you have highly sensitive data that you do not want to share with another organization, so that's a thing that you need to think about. But this is a very fast way of like using these models. The other one is to build. So what I mean by build is it's not you building one of these foundational models which are extremely costly to do, but you could fine tune or you could use your data and extend them and use it in your own organization, within your organization, without having to share your data with somebody else. So that's, for example, that's what me and my team has done at Sapia. I'll talk about it in a bit. So you can fine tune, and then you're actually creating an IP through that. So the first one where this is something you can do. This is an example. One method, like one easy way you can use these things is called retrieval augmented generation, or RAG. The name sounds complex, but it's doing something simple. What it's doing is it's connecting this large language model to your own data set. So, when I mean your own data set, it can be data that within the company that you collected. It can be technical manuals, books, reports, whatever it is. So when you do that, when you connect that large language model to your own data, then you can ask questions about your data where this model is going to now answer. So it's kind of like getting an assistant to read everything in the company, and then you can ask that assistant, hey, tell me this from this report, or what did we decide in this meeting? So if you have meeting minutes. So this is a very common what I call a design pattern, and I think it's something again where you can get a lot of benefits from building. And when you build it, like I said earlier, you can either use an existing model, as in like a commercial model, but then you'll be sharing the data with them, or you can use an open source model like Llama 2 or Llama 3. These are models from Meta, which are open source that you can run within your organization. So then you don't have to share the data. By the way, so if you are familiar with like these cloud providers like Amazon Web Services, they have all these things already available. You can go and plug in your data and use. So it's not like you have to build everything. Something to keep in mind. So yeah, so this is one way you can use it. So the other one that I was talking about was how you can fine tune. So the idea of fine tuning is that you use your data, but then you change a model rather than using it to ask questions. You can extend that model, through your own data. So it becomes more closer to your domain. So it understands your domain more than the general base model. And the idea there is, you've been building your own IP through that, right? Because at the end of the day, most of these existing, what I call base models or large language models like ChatGPT, they are trained on what's publicly available. So I think this point from Chamath is that, so, all of these models are using the same data set. Yes, they tweaked it in different ways, but their knowledge is more or less similar. So if you now fine tune it with your own data that they don't have, where OpenAI or these companies who build these models, they don't have your data set. Now, if you can fine tune a model with your data set, then you have something special. And this is why data is becoming very valuable. If you have a specialized data set, then it becomes very valuable because now you can extend one of these models with your data set and make something unique. So that's something to keep in mind. But it requires a bit of work. It requires more investment. It requires expertise. But yeah, here's an example of that. where, this is an illustration where, a large language model is extended with healthcare data, like, various data from healthcare, whether there's images, prescriptions, you name it. And then you have a model that it knows a lot about that healthcare domain, or maybe your specific institution and what data you have, and then you can ask questions and do things with that specialized model. Yeah, so this is another use case where you can ask, instead of like charts and graphs, you can ask questions from data, and then you can generate things. So I'm just giving you an ideas on, like, how you can use this. All right, now you get to the challenge. That's so great. Those are things you can do. Those are things you, hopefully you got some ideas from it. I really love to see people trying these things out and creating new things. That's great. Now, how do you do it in a responsible manner? But before you get to the responsibilities, like, what challenges are we going to face? Okay, so the first thing is these large language models have a tendency to do what's called hallucinations. So it's a case of where it just sometimes says stuff that was not supposed to be said. Or so this is kind of like that. If you remember the autoregressive model that I just mentioned, it's when it taken apart somewhere that goes into an area that it wasn't supposed to go. You make one or two words towards something else, and then you now suddenly generate what you were not expected to generate. So that means you need to be mindful of those hallucinations. Here's an example of that. So this is a company called DPD that built a chatbot to support their customers, and a customer started asking questions and asked it to write poems, and even asked it to write poems that was complaining about the employer. And it did all that. So that's something to keep in mind. And a lot has been done to prevent these things. So there are ways that you can build your systems to prevent, so which we call guardrails. But it's good to keep this in mind. Then it can also respond with toxic content, like racist content, sexist content. Because keep in mind, it's been trained on open data sets from the web, and on the web you find all sorts of content written by humans, and we know humans. We have sometimes various biases, and you can find content that displays all these biases, but we don't want those to be displayed, within our organization or to our customers and whatnot. So you got to be mindful there, like, it's data that can have, and I'll show you an example in the next slide. And the thing is, it's unpredictable. I'll come to that bit. So this unpredictable part, if you really think about it a little bit, now this is something new, especially even, especially for engineers. Like we try to build systems that are deterministic. I know we can't anticipate everything that might happen, but we want a system to behave in predictable ways for most of the common conditions that it should be under, right? Now, the challenge with AI is that they are by design probabilistic. They are, so you can't expect it to be saying the same, accurate stuff 100% of the time, which is unlike a building or something that you design. For the most part, for the most typical conditions, it will behave in ways that you anticipate. So this is a good example where this was some time ago, though. This is 2018. This was before the whole generative AI, but Amazon built a model based on their resumes to screen candidates, and they found that model was clearly biased against women. I mean, the reason for that is not that the model had any intentions, or that it was biased, because models don't have their own intentions. It just comes from the data that we use and the algorithms we use. So clearly, the data that they used, especially because these were tech roles, had a less representation from female candidates, because that's the nature of, unfortunately, in tech fields, that's what it is. So if you use that kind of data that's really not representative, it is just learning the patterns in the data. So it's going to learn that typically male candidates will have a higher preference than female candidates. It has no idea who's male, who's female. It doesn't have any idea of that, but it's just looking for patterns. And it finds that when resumes mention things like women's studies or hobbies that are more taken up by women, it finds that, oh, when those things are there, those resumes are not going to be very won't have positive outcomes most of the time. So once it learns that, so it's using those patterns to then assess new resumes it gets. So this is a really good case of like, garbage in, garbage out. Right? It doesn't mean that the algorithm is doing intentionally trying to be harmful. It's just that the way we trained it, and we have come a long way from these types of cases. But I'm just letting you know that some of these things are not intentional. It's just you need to be mindful of the data that you're using to build these models and how you use them as well. And then the other thing is, got to be mindful of like what data you share with these systems, because especially in a generative manner, like sometimes you might share data with one of these providers, and they might use that data to train their next model, and then suddenly sometimes your sensitive data might come up in an outcome. It's I'm sure these providers are taking measures not to see that happen, but you have to be mindful of your employees or you yourself, what kind of data you are sharing with ChatGPT and others, and whether it's important to check company policies, or like companies need to have policies around like how they should be sharing data. And now there are better measures in place, but that's also like the privacy aspect of it. Right. So all of these things point to the idea of like building systems in a safe manner. So that and I think as engineers, safety is always a key concern. How do you then think about safety in these AI systems? And I won't be able to cover the full spectrum of it, but I'll just show you like how we think about some of these responsible ways of building these systems. And I asked from ChatGPT like this general question in engineering, not in AI, but how do you build, how do you engineer safety into systems? And this is what he told me. He told me you need to think about protection of human life, regulatory compliance, reputation and trust, financial implications, environmental protection, and ethical responsibility. See, I mean, it's pretty good, right? I don't think I can get that within few seconds searching the web, for example. Right. So then, like, why are we suddenly, like, we've been using software for ages, and we were happy with software. We didn't really worry about we about responsible or ethical use, because we trusted the people who built them, and it wasn't really a big concern like the current concern with AI. It's all coming from this idea of these systems being probabilistic, that they are not deterministic. They are learning things but not following predefined rules. So usually when we engineer things, you have a blueprint, you have a design that you think through, and you could really pinpoint what is happening in each level, and that's how you design a system at the end. You make a design, and then you build on top of it. So they are deterministic. Software has been like that. You define user journeys, you define use cases, and you expect the software to behave in that way. And if it doesn't, we call it a bug, and we fix the bug. I mean, that's how it is. But with AI, that's not how things work. You don't know what it has learned. You expect it to learn something desirable, but it's very hard to go and look into what it has learned from 400 billion words. Like, how do you do that? You can't. So that's why this ethical and responsible use becomes really important. So that's where it's coming from. That's in my view, that's where all the challenges are. And again, for you to form a mental model, I think these are like key components of a machine learning or AI based system. And this is relevant to something that I'm going to show later. So you can see, like, there are multiple components, including the humans, the people who are going to use it. So that's in a whatever the problem domain it is being used, whether it's accounting, whether it's for hiring, whether it's in a scientific domain. The example here is from the domain that I work in, which is hiring, and it's the humans generate the data. It might be in this example I'm referring to hiring, so resumes, interview data, and whatnot. And it's that data that we use, and we use an algorithm, whether it's deep learning, generative AI and whatnot, to build a model, right? So now you can see that the data influences the model. And then the model doesn't live on its own. Like the model doesn't do anything on its own. So the model is then embedded in a system. So if you think about ChatGPT, right? So you're not, you're not directly dealing with a model. There's a chat interface, and you're working with the chat interface, and that system matters because that system can restrict people from interacting with that model or the AI, right? Imagine you build a system that is not accessible to people with dyslexia, for example. I'm just giving an example. Or you build a building where it's not accessible to people on a wheelchair. Now, that way you have now suddenly cut off a whole group of people from using that. So then you don't have data from that group now suddenly. So that interaction part, matters, how you build that system. So it's these components are all part of your responsible use and responsible kind of creation, right? It's not just the model at the end. So you need, because it goes in a cycle then, because then now you build the system, now you collect the data again, now you're going to use that to train the model. Now if you have suddenly omitted the whole section of the population, now you're not going to get a representative data set. So that's why it's very important to think about whether you are building a system, not just the model, that is inclusive to start with. Yeah, I only have 5 minutes. I'm going to go through this a little bit faster now. So there's two things to think about. One is the compliance, that's given, whether it's lawful or not. And I'll show you why I brought the law here. And ethical part. So this is the part that sometimes is unclear. So the kind of the low part of it is now it's high time that we put speed limits, right? Like what we did with cars. And that means bringing laws of how you drive on the road. Same thing with AI, right? So now there are laws on like how cars should be built, what safety measures should be there for it to be roadworthy. So there are legal conditions. So the same thing is happening already now. There are various AI laws and acts coming into place. So maybe the biggest one is the one in European Union called EU AI Act, and in Australia and various other places. So it's good to, like, if you're going to build AI systems and if you're using them, build to make sure that you are aware of these laws. And then the next part is the ethical concerns. And there's by going through a lot of the literature, so this is what I find as the 9 key topics related to ethical concerns when you build and use AI. One is transparency and explainability, which is, can you explain to me how you build this system, what data was used, and how this output was generated, right? That's transparency and explainability. Unbiased. Can you show me that these systems are unbiased against different demographic groups or various groups that matter? And accuracy, obviously, you need to demonstrate to me that how accurate these things are. There's no point building a system and it might be unbiased, but it's not accurate. What's the point in that? And inclusion and accessibility. So this, again, I think I highlighted that. Privacy and data protection. So that's another one. Like, how are you using people's data if you're collecting them? How are you sharing them? How are you protecting them? What about sensitive attributes in them, like demographic details? And then human in the loop. How much human oversight is there in building and running these systems? Safety, especially in physical environment, if you're using them to control the safety, as in not just physical but emotional well-being as well. This is where the hallucinations and sometimes this toxic content from a large language model can impact safety. People will be essentially it will impact the emotional well-being. Accountability, it's interesting. There was a recent forgot from who, a chatbot saying some harmful things, and at the end, the company that was using it trying to distance themselves in the court of law, as in like, hey, AI is acting on its own. We are not responsible for what AI is doing. But it didn't make sense, obviously, because if you build it, you're accountable for it, right? It's like if you build a car and it harms somebody, and it was due to the design, or it's a fault in the design, not in the use, then you are responsible for it. The accountability is really important, and obviously always social and environmental impact. So these things, I put them into, if you go back to the earlier diagram that I showed around how an AI system is built. So there are some things that are directly related to the AI components, the stuff about being unbiased, accuracy and reliability, explainability. But then the safety and inclusivity, it goes beyond the AI. Like I said, it is not just relevant to AI. It's about how you build the system, like what's around it. And AI is just one part of it. And then the outer layer is like people and processes that where you have embedded the system and the AI. So it's around transparency, how you, privacy and data protection. These are all part of, the people and processes that surround them. Not that it's, at the end of the day, these things cut across all three these layers, but mostly, I place them in the kind of area where they're mostly, I guess, take responsibility. So yeah, so I think I'm nearly out of time, but I'll just take 2 minutes to talk about what I do. So I'm the chief data scientist at Sapia. So what we do is we built an AI solution to interview candidates through chat. So essentially what we're trying to do is, we're trying to enhance productivity, or efficiency in the hiring process. But not only that, increase fairness, remove unconscious biases. If you take resumes, they have, like I said, showed earlier, resumes contain a lot of biased information. You see the name, you become biased. There's enough evidence to show how the name matters in a resume. The poor screen, the efficiency and efficacy of the way you screen. There are slow methods, as well as, resumes doesn't give you the right efficacy. And then the poor candidate experience, it's, you send a resume and that's it, nobody gets back to you, you don't learn anything from it. So what we've done is we built this chat interface. It's a structured interview, you do it via chat. Candidates love it because they do it on their own time. They answer questions that are relevant to the role, and the AI behind it, that's what the IP that we've created, that's able to then infer personality traits and various, competencies related to the job and language skills, and then based on that, give people a recommendation so that the hiring manager or recruiter has, then they have this data point to also consider. And it's blind, as you can see. This is not taking any data related to your personal details, how you look, your name. Nothing is used in the AI, just the interview responses. More than 4 million candidates have used it to date. I'm going to skip this. So when we thought about responsible use, we built a framework in 2021, way before the current hype, and we found, these 4 pillars, like inclusivity, being unbiased, explainability, and validity or accuracy being the key things we wanted to demonstrate, and we wanted those to be quantifiable, not just words, but how do you quantitatively, how do you measure and show that the system is inclusive, unbiased? And there's a white paper. If you go to the website, you can download the white paper and read all the details, and we go into detail. But just to give you an example, just to give you an example of sorry, I had a diagram here. It's not coming. Yeah. Sorry, there's a diagram here. For some reason, it's not being shown. I don't know why. It's hidden. Okay, so unbiased, like, we demonstrate unbiased across demographic groups, like say gender and ethnicity, by running statistical tests. And if you're familiar with the concept of effect sizes, So you can show the mean differences between two groups, and we show that it's within a certain tolerance level. So that's, based on our recommendations, right? That means you show parity between groups. And then you can extend that. It doesn't need to be, so gender and ethnicity are by default things we test for. But if there's data for things like, whether somebody belongs to the First Nations people group, if somebody belongs to an age group, disability, we can do testing and show that there is no disparity across the scoring and the outcomes. We can also test for error rates. Like, it's one thing is to show that the pass rates are the same, but we can also look at error rates, like whether the system is making more errors with a certain group than others. So these are ways that you can demonstrate statistically or in a quantifiable way that it is not biased against groups that matter. And I'm gonna end with this. So this is the framework. Kind of, when I say framework, it's a kind of structured set of questions that we developed, especially for companies anyone who's really thinking of acquiring AI. Like, what questions you should be asking. First thing is like really you being knowledgeable about what AI is in general. Then if you are buying an AI system, ask these are questions you can ask from the vendor. What data did you use to build, and then how did you get the data and all of that. I mean, make sure you understand that. What algorithms and how are the algorithms working? This is part of the explainability. Can you interpret and can you explain the outcomes? What problem is AI really solving? Define the problem. Like, just what is it trying to solve? Is it ethical? So this is the ethical part, like those things that I listed earlier. So you can go through them and ask about accountability and whatnot. And how is the model validated and monitored over time? These are key. There can be many, but I think these 6 questions are, I would say, key, and it's good for you to understand of the AI that you're planning to use. I think this is already covered. This is about safe use of systems like ChatGPT. Yeah, thank you. That's it. I'll stop. Sorry, I think I've gone like 5 minutes over. Nandika.
Okay, that's okay. Thank you, Buddhi, for the insightful presentation today. This topic is timely and relevant for all of us. Now I'll open the floor for any questions. If you have a question, please unmute your microphone and ask. Okay, in the meantime, I will ask the first question. Buddhi, you mentioned that you have built many AI solutions. Have you been able to measure impact of successful hiring and cost?
Absolutely, Nandika. So we, as part of I mentioned the validity or accuracy of these systems, we conduct what's called a predictive validity study. So which is, for example, if a company wants to reduce their churn, people leaving, for example, and we could demonstrate that by when they use our system, they by using the scores, and then after say 6 months or 1 year, you can look at the churn within that period and see whether the higher scoring candidates who were hired, did they stay longer than the lower scoring candidates. And this is something that we do, and it is very clear that the system picks people that stay longer compared to the lower scoring candidates that are highly likely to leave. So that's one way. So you can use different measures to validate that. And the other thing is bias, and that's something we monitor continuously. And you could see, compared to the applicant pool, you can see the spread or the distribution in the applicant pool. Say let's simple example, say just taking male female groups. There can be other non-binary groups, but for this example, I'm going to just take male female. So you can see the percentages of male female in the population of the candidates, and then we can show you like our recommendations have a similar split. So that shows that the AI has not made a bias kind of recommendation, so that you can monitor live in our dashboards.
Budi, I have a question.
Yeah.
I'm Senaka. So the first question I have is that, I mean, you don't have to disclose who are your vendors, but in which areas do you get the vendors mostly who are requesting AI-based, hiring, right? That's number one. Number two, you said about compliance with regulations, government regulations. What are the specific regulations that you are concerned about being compliant?
Right. So I think the first one, Senaka, are you asking our customers or are you asking about vendors who are providing solutions to us, I guess, is it?
No, in the first place, I would say your customers, I mean, who are hiring your AI solutions to hire people, right? Yeah.
Yeah. So we work mainly in the high volume recruitment, like where, like retail, hospitality, call centers, where, you get thousands and thousands of candidates and you hire a smaller percentage. So that's where the efficiency and, kind of bias mitigation mainly becomes valuable, right? So those are the industry segments we work in. And I think the second question is about regulations. So there's two types of regulations, mainly around this data and kind of AI systems. So the AI regulations are new. So if you take the EU AI Act, so it is still in like, it's nearly being I guess it's not yet going to be in effect. So it's going through the EU Parliament, and obviously it's going to come into effect. The last time I checked, I think in end of 2025. Don't quote me on it. You can check. But then there are others that are relevant to data privacy and protection, like GDPR. Like every country, and especially EU, already had GDPR laws. So that's around data sovereignty. The various things around data. So we have to be compliant with that. I think anybody who's collecting and retaining and building things with data has to be compliant with GDPR, especially if you're operating in the EU, and similar laws apply in countries like Australia. So data sovereignty, for example, is a key one. So for example, our systems run in each region. So the data within the region doesn't cross regions. So we call it like in-region processing. So for example, the system that is serving the EU is running in EU, when the system that's serving Australia is running in Australia. So the data remains within Australia. So that's something you can do when you use a cloud provider like Amazon. You can create instances in each region because they have data centers. Yeah, that's an example. And there's a recent law that came into effect in the New York City that was very specific to usage of automated decision tools in hiring, where vendors are supposed to create bias audits. So if you're operating in New York City, you need to provide an independent bias audit, which we have conducted for models that are being used in the New York City.
What are the specific in the Australian context? What are specific regulations and the acts that you will be using to be comply with the Australian conditions?
The Privacy Act is the main one for now, right? The others are just being discussed, but it hasn't become law. I'm pretty sure it will happen with the EU pushing for EU AI Act. So because the AI part and because data privacy has been a thing for a long time, and as you can see with some of the recent cases around data breaches and hacking and whatnot, a lot of companies are becoming overly sensitive on that. So that's something we have to demonstrate. It's not specific to AI, but it's specific to data privacy and protection. But that you have to adhere to. Specifically on AI, there's no regulations as yet.
Okay. Thank you.
Other questions?
Okay. Today's presentation by Buddhi has opened up many aspects of responsible use of artificial intelligence. I'm confident we all gain valuable insights. On behalf of the IESLWA chapter and all participants, I want to extend our sincere thanks to Dr. Buddhi for sharing his expertise in this webinar. As mentioned earlier, please remember that if any of you need CPD certificates, kindly send us an email at secretary@ieslwa.org. We look forward to seeing you all at our next webinar. Stay updated through IESLW emails, website, LinkedIn, and Facebook. Have a good night.